because sun transfers energy, right? And could be repoled, minus 30 degrees Celsius. The car is minus 30 degrees Celsius, I'm going in Bismarck, North Dakota. Repoled. And it's sunny day, and everything outside is minus 30 degrees Celsius. The car is minus 30 degrees Celsius. And it's sunny, but everything is cold. You open the car, you go in, you can spend it. It's so hot inside. How can that be? Energy in the form of radiation, photon, right? It's absorbed, right? Travels through the air, and it's absorbed by the material, the glass, and everything that is in the car. It's absorbed. When it's absorbed, it manifests itself as more movement, higher temperature, kinetic energy. Okay? So, in that case, there is a temperature difference between the sun and the inside of the car. Yes, there is a temperature difference, but they are not in contact. The sun is not in contact with the materials in the car either, you know? So, even though there is a temperature difference, that's not transfer of energy in the form of heat. It's transfer in the form of radiation, which we call it in general for anything else, except because of the temperature difference in contact, it's called warmth, right? So it's warmth. The same thing, when you are facing the fire, right? The energy that is transferred is in the form of radiation, warmth. And when it's absorbed with your blood, whatever your hand, it manifests itself as kinetic energy, right? If the temperature goes up, because now that photons were absorbed by the particles of your hand. When you're like this and you're facing the fire that way, now you cannot absorb radiation. Radiation flies for small distances, really straight line. So if you're like this, it's not going to go like that and come to your hand. Radiation is not going to go like this, it goes like that, straight. Right? So you don't get it through radiation, but it gets warm. I mean, I'm 37 degrees Celsius and now I got real hot. Because the room is hot, right? Why is the room hot? The molecules are moving in an average way more vigorous than the particles of your hand. So now there is in contact your hand, which is 37 degrees Celsius, with the room which is probably 40. That's why you feel heat, hot. And there's energy transfer in the form of heat from the molecules of the air, right, into your hand. These are two systems now, right? The room, the air, and your hand, right? There is energy in the form of heat because there's temperature difference and they are in contact. The air is in contact with your hand. Everybody got it? Okay. So it should be, 7 should be W, and 8 should be 2. Okay, so we have 9. Your hands get warm, and by you, B, by rubbing them against each other. So your hand is 37 degrees Celsius, right? If you have a thermometer, you put it there, it's not going to be 37 anymore. It's going to be higher, maybe 39, 40. How that higher temperature came to be? Because energy was transferred to it. And now, how that energy was transferred to it? In my hand. Warmth, the form of warmth. Friction, right? Movement, right? Macroscopically movement, right? So that should be, then 9 should be warmth. W. Your hands get warm by holding a hot of cup of tea. Again, there's a temperature difference, they're in contact. So that should be, 10 should be 2 in the form of heat. Tires of your car, it can be really cold outside, right? The road, the tires, everything is, let's say, minus 50 degrees Celsius, really cold, like Colorado, whatever, Michigan. And you make a trip of 3 hours without stopping. Did you ever try to put your hand in the tire? Did you ever try to do that? It's really hot. You try it. Take a trip, even now when it's cold. When you take a trip, 3 hours continuous on the highway, go and touch the tire. See how hot it is. Sometimes you cannot touch it. If you try it for 6 hours, it's so hot you think you will burn your hand. That hot. Why? How did that become so hot? It's the friction on the road. Continuous friction. If there was no friction, the tires would not rotate, right? But there's friction. So it's actually then from the road to the tire, the temperature is the same. So why there is higher temperature? How that energy came up to be? The work, right? Energy in the form of work was transferred. Okay, and what becomes cold in a car? We already talked about it. Should be 2. A hammer's head becomes warm after being used to hit nails for a long time. Right? You can do this all for a long time, and the hammer becomes hot. The nail and the hammer is the same temperature. How can that be hot? Again, you do work. Right? You add energy to that hammer in the form of work because of your muscles. Muscles do work. You're moving your hand. So 15 should be W. And 14, now you're holding the hammer, right? So the hammer, let's say, is 5 degrees Celsius. You're holding your 37 degrees Celsius. From higher temperature to lower temperature, always energy flows from higher temperature to lower temperature body. So this is going to be the form of? No. The form of heat, right? Okay, let's do a few more problems.
Question?
Yes.
Why is 7 work if 8 is
Why what?
why are 7 and 8 the way that they are?
Oh, we went over that.
No, they're reversed.
At the end.
No, aren't
You
they?
stay at the end and I will explain again, but not again because we already talked about it for a long time. So at the end, feel free, I'll be here and I will explain it to you again, okay? Let's see this problem over here. Okay, that's an interesting problem, as you will see now. Have you done it before? No? Is it in the reader? It is? Well, let's see how you are really answer, because many times you might do problems, but you need a little bit more to really understand it more. Oh, there they are. Welcome. Okay. Okay, let's do this problem and then we're going to have fun, right? Yeah. All right. So have a seat, and in about 5 minutes we'll.
When you say the word normal, does that just mean standard atmosphere? When you just say the word normal,
this is the definition. Do you remember? Normal boiling point, normal melting point. Normal means, what does it mean? External pressure is 1 atmosphere, right? Because the melting point and boiling point depends on the melting point and boiling point depends on external pressure. So that's why we define normal to have kind of a standard reference for, by definition, where the external pressure is 1 atmosphere, okay? So, if we want to do this problem now, then, let's see how we think to do it. Because if you see the answer, you will already understand the problem. You really need to do the problem to find out the difficulty, see the difficulty, how you will think to do it. Okay, so we have the triple point. Triple point is equal to 20 degrees Celsius and 0.75 atmosphere. So this is pressure, right? And this is temperature. So this is triple point. So we have normal boiling point, and melting point, normal. So melting point is 35 degrees Celsius, and boiling point is 200 degrees Celsius. So this is okay. So you remember that the phase diagram, we have two axes, right? And the vertical line stands for pressure, right? And that pressure could be vapor pressure of a liquid or a solid, or it could be external pressure. You can have double roll, right? These people are not scientists. Are you scientists? You never took chemistry? Oh, you must be bored. Maybe I have to do this fast, right? All right, so you learned some science, good for you. Okay, so pressure is here, that, as we said, that has a role too, right? External vapor pressure of solid liquid. And here is the temperature, absolute temperature. You can put degrees Celsius in this. You remember, we have a kind of a thing like this, right? Something like that, something like that. Sometimes it goes like this, sometimes it goes like that. So we don't really know which one to put it. Remember that? Usually this one is the same always, and then that's the triple point. And then there is a line like this, or like that. But we don't know what to do now. We have to figure it out. Right? Yes? Okay. So we have three areas. 1, 2, 3. As we draw a line, you go from lower temperature, solid, higher temperature, liquid, and higher temperature, gas, right? So I'm not going to put solid here. So let's say this is the line. We don't know what it is, somewhere there. We'll find out, right? And we have three areas, 1, 2, 3. Where am I going to put the solid? There, solid here, solid there. Where am I going to put the physical states? You think this way. Here's a line, imaginary line. You increase the temperature. If you have very low temperature, the substance will be solid, right? So it will be solid. This is solid, right? We should put this line a little bit above there. This imaginary line, something like this. So as you go the temperature up, you're in the solid area, you're in the liquid area, right? And then as you go up, we have the gas area. So here's the imaginary line, solid, liquid, gas, right? So this is the solid, this is the liquid, and this is the gas. You see that? So you remember the order. Okay, so the triple point should be right here, and therefore should be, this is the temperature, which is how much? 20 degrees Celsius. And then you have also 0.75 atmospheres. So this one is going to be 0.75. So these two numbers correspond to the triple point, which is the external pressure and temperature that all the substance is found in all its three physical states, solid, liquid, and gas equilibrium, right? And then, whatever we have to do, we need to put now beside these 2 points, which define the triple point, we need to put 2 more points. And these are the normal boiling point and the normal melting point. Okay, how are we going to find this? Let's see. The normal boiling point and melting point is defined with external pressure of 1 atmosphere. So if this is 0.75, here's the triple point, right? Here's the hard part, okay? To make it correct. We need to put these 2 points, right? There's temperature here. So if this is 20 degrees and that thing is 25, 25 should be higher than 20, so it should be somewhere here. And the other one is what? 200. It's going to be much higher, right? So now, 25 is what? Melting point. All right, 25 is melting point. So if this is 0.75 and this normal boiling point and normal melting point is defined with 1 atmosphere, right? I'll choose one by 1 atmosphere, that's somewhere here. What do you mean somewhere here? Well, it has to be higher than the triple point, which is 0.75. If this is 0.75 here, 1 atmosphere should be higher than the triple point, so it should be somewhere there, correct? Okay, so we have this imaginary line at 1 atmosphere now, imaginary line 1 atmosphere. And wherever it crosses these two lines, down there will give us the corresponding normal boiling point of melting point, right? So, let's see. This one stands between liquid and gas. So, between liquid